Hello students, this is the video number 10 for the third chapter laws of motion, and part C will discuss in that 9th standard physics. So in this part mainly we will discuss linear momentum and Newton's second law of motion. Newton's second law of motion. First, we'll discuss about linear momentum. So linear momentum is represented by P letter and it's a vector quantity. It is the product of mass and velocity. M is the mass, V is the velocity. So SI unit of momentum is, for mass it is kilogram and for velocity it is meter per second. So this is the SI unit, kilogram meter per second. Momentum is a vector quantity, that's why it is represented by this P vector. It is a vector quantity. Second is its CGS unit. So CGS unit is for mass it is gram, for velocity it is centimeter per second. So this is the CGS unit. Now we'll try to get one of the small derivation, that is the rate of change of momentum. Rate of change of momentum. So let the body initially moving with the u velocity of mass m. So initial momentum of a body will be m into u. Mu. M is the mass, u is its initial velocity. Then we will have final momentum, because under the application of the force its velocity will increase from u to v. So finally it is moving with the v velocity. So its momentum will become m into v. So what will be the change in momentum? Change in momentum. So change in momentum is final momentum Pf minus initial momentum Pi. So Pf is mv minus mu. Simply I can take mass as common. So it is mv minus u. Let it be as delta P. Delta means change in momentum. Delta means change in momentum. So rate of change of momentum. Rate of change of momentum is equal to change in momentum upon time, the time taken to get the change. So change is what? mv minus u upon t. So if we'll consider this factor, so this factor is what? Change in velocity upon time, that is acceleration. So rate of change of momentum, rate of change of momentum, that is equal to mass into acceleration, and which is equal to external applied force. This ma in magnitude is equal to applied force. Okay. So after that, there's a definition of this Newton's second law. So the definition you can read from the book. I'm simply going to explain you this expression. So according to Newton's second law of motion, the rate of change of momentum of a body is directly proportional to the force applied on it, and the change in momentum takes place in the direction of the force applied. So this delta P I can write as m into delta V upon delta T. Why I am taking mass out from this delta? Because mass is one of the factor which remains constant. Delta V upon delta T is what? That is acceleration. So mass as it is, acceleration I can write as delta V upon delta T also. Okay. So after that, so we know that force is equal to mass into acceleration. Now out of this we have number of cases. For example, if in first case, if mass is constant, so this force is directly proportional to acceleration. For this I can draw the graph. To this side I am taking acceleration and this side I am taking force. So both are directly proportional. So this is the case when mass is constant. Case number 2. When acceleration is constant. In that case also, the force and mass, they both are proportional to each other from this relation. If this acceleration is constant, then force is directly proportional to mass. Messy with the body, more force you have to apply to get constant acceleration. Less will be the mass, less will be the force for the same acceleration. Case number 3. When force is constant, from the same relation, if this is constant, then acceleration is inversely proportional to mass. In that case, acceleration mass graph will be in this way. Force is a constant. So this kind of graph you will get when the force is constant. And then examples of second law of motion in daily life. Even we can obtain Newton's first law of motion, from second law of motion. Second law. How it is possible? As you know, force is equal to mass into acceleration. Now, if F is 0, because in first law, we know that if F is 0, acceleration will also be 0. So, we will not apply any force, or under the absence of external force, the body on its own will not change its state of rest or motion. So, if no force is applied, acceleration will also be 0. So, that is from second law. F is equal to ma. This expression we got from second law. If F is 0, then acceleration will also be 0. And this also we know F is equal to delta P upon delta T. Now, while catching a ball, the cricketer withdraws his hands along with the ball. Why he is doing like that? Because if delta T, he will increase. Delta T, if it will increase, change in momentum he can brought with the less force. Because delta T, if it will be less, force striking of the ball with the cricketer will experience less force. And even when glass vessel fall on a hard floor, that will break. Why it will break? Because on a hard floor this delta T will be very, very small. Delta T will be very, very small. That is the time of collision, time of impact. If it will be very, very small, this force will become large. And under the influence of this large force, that glass vessel can easily break. So, number of examples are there. That also you can study, read it properly from the book and try to correlate this taught part C in this video number 10 with that content. Thank you very much.